So let's say we have to solve 4 equals x squared plus 6x minus 5. Now there's lots of ways to do this, but because we're learning the completing the square method, we're going to just use completing the square, and then we'll talk about some other ways you can do this too. But let's try completing the square. For now, I'm going to leave the 4 over here just because I can. And then for those of you who are a little more visual, we can build the x squared plus 6x minus 5 and see what it looks like. I'm just going to do that over on the side. So I have what? 6x's. So here's 3 and 3 more makes 6. So I'm just going to place those up here because usually, since I'm trying to make a square out of this, I have my little x squared, and then 3x and 3x is 6x. So I usually just split that right in half. So far, this is x squared, or I'm sorry, this is x plus 3 squared, but it would normally have 9 little single units in here, so it's minus those 9. So I'm going to call this x plus 3 squared minus the 9. Then I would need to really have a complete square. So instead of saying this part, x squared plus 6x, I'm going to call that x squared. I'm sorry. I'm going to call that x plus 3 squared. Let's just erase that. Minus 9. Okay, so that's instead of writing x squared plus 6x, I'm going to write x plus 3 squared minus 9. But then remember, I also have that minus 5 over there. That was in the original problem, so I have to keep that there too. And that still all equals 4. So everything else stayed the same, but I rewrote this part because I want to solve this by completing the square. So I'm just going to simplify that side up a little bit. Now I have x plus 3 squared minus 14. So I know some things. If I were to draw this parabola, the vertex would be at -3, -14. And this time, I would want to look on the graph somewhere else, not at where y equals 0, but actually at where y equals 4. So first I'm going to finish solving this using this new form that I've written it in. So I would, of course, add 14 to both sides. And now I have 18 equals x plus 3 squared. And if I take the square root of both sides, I can get that x plus 3 all along, because the square root kind of cancels the square. So the square plus or minus the square root of 18 is equal to x plus 3. And then my last step would just be to subtract 3 from both sides. So now I have plus or minus the square root of 18 minus 3 is equal to x. That would have been virtually impossible for me to find on a graph. Now I could take out a calculator and get a decimal approximation of what the square root of 18 is, but for the sake of argument, realize that 18 is between between 16 and 25, so it's going to be around 4.2. If you want to estimate the answer to that, that's fine, but this answer is just fine by me. Let's take a look at the graph now and see how that relates to our answer. Here's the graph of y equals x squared plus 6x minus 5. So I see that it's just a regular parabola, which I expected. Also, it would have been real easy to graph using -3, -14 as my vertex, and then just drawing a parabola, a regular parabola. The difference here is that Now, instead of equaling 0, y actually equals 4. So the graph of y equals 4 would be a straight horizontal line right here. It goes all the way across. There's y equals 4. My two answers are here and here. Remember, one of those is negative square root of 18 minus 3, and one of those is positive square root of 18 minus 3. And that's where they are. So it's pretty easy to solve for as long as you know how to complete the square like this. It just takes a little practice.